Welcome back, guys. All right, today's Monday, March 30th. Okay, we've got a couple more lessons, guys, before spring break. Okay, so let's push through. Let's get this done. Make sure you're keeping up with your assignments. So last week we talked about probability, but the probability that we talked about was the probability of a single event occurring. And we said that the probability was the number of desired outcomes over the total number of outcomes. The total outcomes. So going back to the example of rolling a die, right? If we said what is the probability of the single roll, the single event, being an even number, well, there were 3 even numbers out of 6 total. 2, 4, 6. That's 3 out of 6 total rolls. 1, 2, 3, 4, 5, 6. And so we would do 3 over 6, and the probability, we can reduce the fraction, change it into a decimal, change it into percentage, and it became 1/2. So we had a 50-50 chance. Okay, it was equally likely to get an even number or an odd number when you roll a die. When we're talking about the probability of multiple events occurring, this is called compound probability. Okay, so as you can see right here, compound probability. The probability of multiple events occurring. So we're not talking about a single event, we're not talking about a single roll, we're talking about multiple rolls, multiple flips of a coin, or something along those lines. We need to know something about the different events that are occurring before we can find their probabilities. What we need to know, okay, so everything today will be based around this fact, is are they independent events? Independent events. What is an independent event? Well, here's the definition right here. Okay, an independent event are events in which the outcome of one event does not affect the outcome of the other. So 2 events occurring, okay, multiple events, 2 events, we could say 1 event and then the next one. The first event does not affect the second event. Whatever happens the first time is not going to change the probability of the second one. It has no impact on it at all. So let's talk about some examples of independent events. Okay, so there are multiple different types of examples of independent events. One of them, kind of staying on the same topic of different examples we looked at before, is flipping a coin. Heads, and I have tails. So flipping a coin is an independent event because the first time that I flip it, I'm either going to get heads or tails, right? There's my flip. This time I don't know if you can see it, I got heads. Now the second time that I flip the coin, the fact that I just got heads does not change what I'm going to get the second time. It does not impact at all. So even though I just got heads, this time when I flip it, I have the same chances. I got heads again. Okay? And I could keep on getting heads over and over and over again, but no matter what, each time is the same chance of getting heads or tails each time. It does not, the last flip does not affect the next flip. Okay? It's independent events. Another example, staying on the same topic, rolling a die. Every time that I roll this die and I get a different number, the last roll doesn't affect the next roll. Just because I got a 1 the first time, that doesn't change my chances of getting a different number the second time. They're independent events. Okay. Now you could also combine the two. Okay. Flipping a coin and rolling a die, those are also independent of each other. If I flip a coin, that's not going to impact what number I get on the die. They're independent events. So they can be completely unrelated, or they can be the same means of probability over and over again. So that's independence. Now that we know what independent events are, how does that affect the compound probability? Okay, reminder, compound probability is the probability of multiple events occurring. Well, so the rule for finding compound probability of independent events, okay, everything we're doing today is independent events. All you do is you find the probability of each event individually, then multiply those probabilities together. So you're going to have multiple events. Let's say you have 2 events. You'll find the probability of the first event, find the probability of the second event, and then you multiply those probabilities together to get the compound probability. Okay? So the way we can write this, we can say the probability of event A times the probability of event B. Okay? that will be the compound probability. That will be the probability of A and then B. So remember, A and B are just some events. The probability of getting A and then B, the compound probability, as long as A and B are independent, we just take the probability of A times the probability of B. So example 1, we're going to look at flipping a coin again. So flipping a coin, I have heads and I have tails. Okay, I want to know the probability, the compound probability of flipping a tails and then heads and then tails again. So in this example, I have 3 events. The event of flipping a tails on the first flip in this order. Okay, the order matters. The flipping a tails on the first flip, a heads on the second flip, and then a tails on the third flip. Well, first thing we need to determine is flipping a coin independent of each other. And that's what we just talked about. We already considered, yes, flipping a coin is independent. The first flip is not going to affect the outcome of the second flip. The second flip is not going to affect the outcome of the third flip, etc. We need to find the probability of each of these events occurring individually. So the first flip, okay, so here's my first flip. Okay, what is my probability of getting tails? There's 2 outcomes, heads or tails. So we know it's going to be out of 2, and we're looking for one of those 2 outcomes, which is tails. So we have 1 desired outcome out of 2 total possible. So the first flip, our probability of getting tails, so this is the probability of getting tails, is 1/2. Because it's independent, the second flip, the probability of getting heads, because these are independent, even though we got tails the first time, it doesn't matter, it's still going to be 1/2. That's the probability of getting heads on the second flip. We want to get tails. The probability of getting tails is 1/2 on the third flip. Because it's independent, it does not change the last flip. The first flip doesn't affect the second flip. The second flip does not affect the third flip. Our probability is going to be 1/2 every time. So we found the probability of each individual event. This event, then this event, then this event. So the total probability of all 3 of them, the compound probability, we'll be taking each of those individual probabilities and multiplying them together. So 1/2 times 1/2 times 1/2. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So the probability of flipping a coin and the compound probability of getting tails and then heads and then tails would be 1/8. Or if we wanted to change this to a decimal, that's 0.125, or you could put 0.125. Or we could change it to a percentage. You just move the decimal over 2 places, or you can think of it as multiplying by 100. Okay, there's multiple ways to get to percentage, but those are 2 ways you can think of it. Either moving the decimal over 2 places, or multiplying by 100. So that would be a 12.5% chance. So if I were to flip this coin 3 times, I have a 12.5% chance that I will get tails, then heads, and then tails. For the second example, I'm going to be talking about the game Yahtzee. Now some of you may have played this before, or maybe you've never heard of it before. So I'm going to explain it. So in Yahtzee, you have a cup. Okay, it looks something like this. And you have 5 die. In the game Yahtzee, you put the 5 die in the cup, you shake it up, and you throw the dice.
You roll the dice out of the cup. On your first roll, you roll all 5 dice. Set any keepers aside. The second and third rolls, you can re-roll any or all of the dice from any previous roll, setting aside keepers when necessary. You may stop and score after any roll. After the third roll, you must score. A Yahtzee is unique. Getting 5 dice of the same number is a Yahtzee. The first Yahtzee you enter in the Yahtzee box is worth 50 points. For each additional Yahtzee, you earn a bonus 100 points.
What we're going to look at is what is the probability of getting Yahtzee on the first roll. We are going to be rolling 5 dice, and each roll, each individual die that gets rolled, the outcome of the next die is independent of the original outcome. So if I roll 5 dice, the first die, whatever I get, is not going to impact the second die at all. Okay, they're completely independent. So because of that, to find the probability, okay, so the probability of, I'm going to say Y, which is for Yahtzee, so getting 5 of the same number, we can find the probability of the first one, and then the second one, the third, the fourth, the fifth, and then multiply those all together because they're independent, because rolling dice are independent events. So, the first roll, now the first roll, it doesn't matter what number we get, right? We can get a 1, 2, 3, 4, 5, or 6. So it doesn't matter. Whatever number we want to get, let's just say 3 for the sake of the example, okay? So let's say we want to get 5 3s in a row. The probability of getting a 3 on the first roll, well, there's 6 possible outcomes. We can roll a 1, we can roll a 2, a 3, a 4, a 5, or a 6, and we want a 3. So that's 1 of the 6 rolls out of 6 total. So we have a 1 out of 6 chance of rolling a 3 on the first roll. Okay? Well, I know that the second roll is not going to be impacted by the first roll because these are independent events. So the second roll, my probability is still going to be 1 over 6. Okay? And you might be able to see where this is going. So the probability of getting a Yahtzee on the first roll, on the first try, would be multiplying each roll, the probability of each roll together. So 1 out of 6 times 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 1 out of 6. So 1 out of 6 multiplied 5 times. Which gives me, if I do 6 times 6 times 6, well, I have 1 on the top. 1 times 1 times 1 times 1 times 1 is just 1. So I have a 1 out of 6 times 6 times 6 times 6 times 6, which is 7,776. So I have a 1 out of 7,776 chance of getting a Yahtzee on the first roll. So, in other words, that's not very likely. 1 out of 7,000, almost 1 out of 8,000. Let's put that as a percentage to see what it goes to. That is, okay, I'm going to write it up here since I'm running out of space. Okay. That is 0.0000, and I'm going to go 1, 2, I'm going to round up to 9. That's as a decimal. As a percentage, I have to move the decimal over 2 places or multiply by 100. They mean the same thing. So as a percentage, I'll write it up here. That is 0.0129%. So less than 1% chance of getting a Yahtzee on one roll.
George!
Ow!
What happened?
I don't know. Cody and I were playing a fun game, and then I looked down and... Yahtzee!
Alright, now that you finished watching the video, go take the quiz on Google Classroom, on Google Forms. Make sure you read the questions carefully, especially the last one. There's a hint on there and a little bit of a note, so make sure you read it very carefully. If you have questions, let me know. Okay, if you don't understand what it's asking, just let me know and I'll be glad to help you. Also, don't forget to take that survey. That's going to be important for the lesson later this week because I'm going to use your answers on the survey to teach the next part of probability. Okay, so make sure you answer that, please, and do the quiz, and let me know if you have questions.